Hello again, it's Dr. Ock from Mind's Eye Models, maker of organic chemistry model kits and general chemistry model kits for the spatially impaired. Today's discussion is going to revolve around geometric isomers in molecules. Specifically, we're going to talk about cis and trans molecules. When carbon-to-carbon bonds form double bonds, the formation of cis and trans isomers becomes a possibility. In cis isomers, the substituents that come in and out of the double bond are on the same side of the double bond, whereas in the trans isomers, you can see this methyl group and this methyl group, one is coming in from the bottom and one is coming out from the top, so they are opposite each other. The molecule I've chosen here is a very simple one. It's 2-butene, and so 2-butene, when the carbon-to-carbon double bond is between the second and third carbon, you have the possibility of having cis and trans isomers for that molecule. Now with our kit, you can very easily prepare these, and I have prepared ahead of time, for the sake of time, the cis 2-butene model. You can see here's the carbon-to-carbon double bond, and I think that this model kit really sets itself apart from the others because of the realistic representation of the double bond. Remember, double bonds consist of a sigma bond between these two carbons and a pi bond where the unhybridized p orbital that remains overlaps above and below the axis of the sigma bond. You can see here that the methyl groups are on the bottoms on the same side, and we have carbon to hydrogen bonds in the back. What's very realistic about this model kit that isn't in many others using balls and sticks is that you can very easily see how the rotation around the double bond is impeded, because for me to completely rotate this around, I would have to break the second pi bond of the double bond, and there's too much energy for rotation to occur without breaking that bond. Now what I want to do is very quickly assemble the trans version of this molecule so that you can see how quickly you can put this together. Here are my two sp3 hybridized methyl groups. I'm going to very quickly turn them into methyl groups by adding a carbon to them. 1, 2. And then I'm going to use my sp2 hybridized trigonal bipyramid to create the carbon-to-carbon bond that will be the double bond in the middle here. The methyl groups are now going to be opposite each other, so I'm going to put those on quickly. One in the back and one in the front. And you can quickly see that we're starting to assemble the carbon skeletal structure very easily. Now I've prepared one of the pi bonds separately, again to just save some time, but here's where these elbows that we're using in the kit are going to come in handy. I've used an elbow in each of the corners, using a very short piece to represent the p orbital coming up, and then here is a carbon-to-carbon bond, and then I just place that on the axial prong of the sp2 hybridized carbon for the top half of the pi bond, and then I'm going to take two more short pieces of carbon and I'm going to use elbows for those as well. There's the first one, and now the second one. And then I'm going to put the carbon between them to connect them, to simulate the overlap of those p orbitals, and then I'm going to take that piece and attach it to the bottom, completing the double bond. And then the last thing I want to do is to put the hydrogens so that you can easily see the trans isomer compared to the cis. Again, in the cis isomer, the methyl groups are on the same side of the double bond, and in the trans they are on opposite sides. I think these models do an exemplary job of displaying carbon-to-carbon double bonds, especially with regard to the existence of a sigma and a pi bond and the impedance to rotation around that carbon-to-carbon double bond that the pi bond creates by its very nature. Again, I hope this is helpful and helps you in your chemistry studies. I know that our models can help you to see this better, and we look forward to hearing from you. Again, we're Mind's Eye Models, and we can be reached at www.myspace.com/mindseyeModels. One big word. We hope to hear from you. Bye.